Okay, this is page 2 of the fault tolerance notes, and section 2 is about clock synchronization. And the text reference is 13.4. And so we're going to talk about where you have multiple devices. We can call it a distributed system, and they each need to keep track of the time, and they need to somehow agree with each other on what the current time is. Their clocks are not perfect devices, and they're prone to drifting over time. So distributed components will have their own clocks, and these clocks are typically made from quartz crystal oscillators. So they'll take a thin piece of quartz, usually it's an artificial quartz, and they'll put electrodes on both sides of it, and as a voltage is applied across it, the shape of the crystal will change, and then when the voltage goes away, it returns to its original shape, creating an electric field. And so this can be put into a circuit to create an oscillator. So clocks are made from quartz crystal oscillators, and these can be affected by temperature and also by the supply voltage. So something in the neighborhood of 0.5 seconds of drift per day is not unusual. So options to maintain a common time in a distributed system are: 1, have a standard clock. So keep a high precision clock that you trust, and we'll call that C sub S, against which the other clocks synchronize. This is common, so for example the network time protocol, that's how it works. So your computer checks in once in a while with the time server and updates its clock. And we're going to talk about something called precision time protocol, which is used in things like laboratories and stuff to do very precise clock synchronization. So that's one, and the second option is that they can synchronize with each other. This might be more appropriate if a high precision standard clock is not available, and what's more important is that they're able just to agree on what is a common time rather than what is the exact time. And so the first method here we can call centralized, and the second method is distributed.